All right, guys, so we're going to go ahead and talk about molecular solubility. If you're watching this video on your own, remember you can pause it at any time to jot down any of the notes. And if you're watching in class, try to just follow along and get as many of these definitions and notes down as possible. But remember, you not only have access to this video, but you also have access to this PowerPoint online. Okay, so let's start with some new vocabulary. The first one I want you guys to know is solute. The solute is the substance that is dissolved in the solution. So for instance, in the background section that was given to you on the lab or the demo handout, we're talking about Kool-Aid dissolved in water. Kool-Aid is going to be our solute. But before Kool-Aid can be dissolved, it needs to break the IMFs with it, or between those molecules of Kool-Aid. So these are all our different molecules of Kool-Aid. And in order for Kool-Aid to dissolve, it needs to break those IMFs. In the demo that we're going to do today, crayon wax is going to be our solute. We are trying to dissolve crayon wax. So specifically, we're going to pay attention to decane, which is one of the hydrocarbons that is in paraffin, which is what crayon wax is made out of. The next definition is going to be the solvent. Solvents are what break down another substance in a solution, and it's typically a liquid. So for in our Kool-Aid and water mixture, water is going to be our solvent. And again, before the solvent can interact with the solute and dissolve it, it needs to break its IMFs in order to do that interaction, okay? In today's demo, the solvents that we are using are several different types. We have 5 different solvents. We have ethanol, acetone, water, hexane, and turpentine. So we will talk about what's going on as far as IMFs in each of these based off of their bonds and if they have molecular polarity. But you just need to know right now that these 5 different liquids are the solvents, which are trying to dissolve the solute or the crayon. And then the final piece of terminology you need to be familiar with is this term of a solution. And that's just a mixture of substances where one is distributed throughout another, or we dissolved one substance in another. So for Kool-Aid and water, Kool-Aid being our solute and water being our solvent, when we mix them together, they're evenly distributed and we have created a tasty glass of Kool-Aid. Before I show you guys the demo, I want you to remember that making a solution is not a chemical reaction. We are able to reverse it through physical means. For instance, if you boiled your Kool-Aid, you would eventually evaporate all of the water and be left with Kool-Aid, again, just powderized Kool-Aid. So it's not a chemical reaction. So let's go ahead and take a look at how effective each of these solvents is on our solute. Right here is all crayon wax. You can see that I've drawn it in here. This is our solute, okay? I'm going to rub these each 10 times back and forth. So this is water. 1, 2, 3, 4. The next one is ethanol. Now that looks shiny just because it's drying. That's the light, so let it dry. Acetone. Again, this one's drying a little bit. And we have turpentine, or sorry, hexane. This one's not drying, it's already dry. And then finally turpentine. Okay, so you can, it may be hard to see how much it got through, but you can see how much of the crayon was actually moved off. This is just wet from the water still. So take a look. Which one do you think was the most effective at dissolving the solute, the crayon wax? Which solvent, one of these guys, was the most effective? And which one was the least effective at dissolving the solute, the crayon wax?